All right. So specifically, our topic for today is called function tables. Function tables. So I'm going to write that down. And this term function is going to come up quite a bit, not just this year, next year for sure, and when you take algebra, and then algebra 2, pre-calculus, calculus, you're always talking about functions. So this is kind of going to be our first dip into it. So we're going to write equations in what's called function form. So let me write that down. Function form. And it's a specific way of writing an equation in two variables. But we're going to stop calling this form of writing an equation function form almost as soon as we bring it up. So in about a week and a half, we're going to no longer call this way of writing an equation function form. We're going to call it by its other name. So I may as well just tell you what that is now. It's going to be called slope, intercept, form. So whenever we say function form or slope intercept form, it's going to mean the same thing. And here it is. It's just a way of writing an equation in two variables. And so an equation in function form, also known as slope intercept form, looks like this. Y equals, it's always got y equals. And then we're going to use the letter m because it's going to mean something. I won't tell you what it means today, but we'll get to it. X plus b. Y equals mx plus b. Okay? You will definitely have that etched, burned, blasted into your memory by the end of the year. Y equals mx plus b. To the point where when you start talking about it in algebra, you're like, oh, this is so easy. Okay, so let's talk about what this all is. So it all starts with the word function. And a function is just a rule, a specific rule for two items called an input and an output. Okay? And we'll get into the specifics of that rule eventually. Today, all I need you to know is that m and b are just going to be numbers. So we'll ignore those. But the variables that we're going to play around with are x, and x is going to be our input. Meaning we put a number in, and then we'll get a result out. So the number we put in will be x. So x is often called the independent variable. So this is going to be our independent variable, and it's going to be x. It's the input. Now the thing that we're going to have as an output, our result, is going to be whatever we get for y. This is going to be our output. And this we call the dependent variable. Meaning the answer for y is going to depend on whatever we pick for x. So this is going to be our output. Now, every year, we all have to do our taxes, right? Your parents, you hear them talk about doing their taxes. Or sometimes you wait on your tax returns, meaning the extra money you get back from paying taxes. And whenever your parents fill out their tax forms, they're asked, do they have any dependents? Meaning you guys. Do they have anyone in their household who they're paying for? Usually it's your kids. It could be maybe an older grandparent or someone that you're helping support or something. But those are dependent. Someone or something that depends on something else. Okay? Now, after all of this, if we do everything correctly, we're going to have an ordered pair. You guys remember what an ordered pair is? A pair of numbers like this. This is my ordered pair. So all of this will result in getting a pair of numbers, a number for x and a number for y, that we can then graph. Okay? So let's go ahead and do this. We're going to look at some function tables that's going to give us some ordered pairs. Okay? So we're going to complete the function table below. Now, if you're good with number patterns, this is going to be super easy for you, because a lot of that is just picking up on the patterns. And I'll help you out with that. Okay? So I'm going to give you a function table that we're going to complete. The first one. Okay, you guys ready? So here's our first function. This is a function, y equals 5 times x. Okay? And, all right, let's do this. Usually we have some inputs and some outputs. So we're going to have those. So I'll pick 0, 1, 2, and let's do 40 as an okay. So I want you to make that table. So I have 3 inputs, 0, 1, and 2, and 1 output, 40. And we want to figure out these missing numbers. Okay? And we got a rule, don't we? We got a rule. And the rule is y equals 5 times x. That's our function. So it's 5 times something. Each and every time it's 5 times something. Well, let's see. You got to do a little math here. You ready? So we're going to enter in our inputs here. This is kind of, maybe sometimes you would do this in your head, but since this is our notes, we're just going to write it down. And so we would do 5 times 0. Here it would be 5 times 1. Here it would be 5 times 2. Well, this one is 5 times something, but the answer should be 40. So in this one, we know the answer. We got to figure out what the input would be. Let's start. Let's start with 5 times 0. How much is that? 0. So 0 goes here. So the first ordered pair is 0, 0. Then we would have 5 times 1. That would be 5. Then 5 times 2, you see the pattern? That would be 10. Now 5 times something equals 40. What does that something have to be to get an answer of 40? 5 times 7? 5 times 4 is 20. Well, you can always try. That's the beauty of it. 5 times 8. 5 times 8 is going to give us 40. So the input would have to be 8 to get an answer of 40. Okay? So that's the beauty of it. You can always guess and check a little bit till you get the right answer. Okay? You guys ready? Let's do another one. Number 2. So this one, let's do y equals 2 times x, and then we're going to add 6. So this one looks more like this equation. The m value is 2. You see m is 2, and the b value is 6. So that looks more like a regular function form or slope-intercept equation. Okay, so here we go. X and y. Okay, and these, remember, which one is the independent variable? The x. So independent means you're free to pick whatever you want for x. And sometimes you're going to want to pick certain numbers because of whatever the problem is about. And other times you just want to pick whatever you want. So what number shall we pick? Could be anything. 1 is a good one. What else? 3, okay. And you want to do 7? Let's do 7. 1, 3, and 7. 3 odd numbers. Why not? Okay, so here we go. What I'm going to do is I'm going to put the actual function 2 times something plus 6. 2 times, I'll use parentheses for whatever number x is, plus 6. So here we go. So let's put in the numbers we picked. Let's find those numbers that we picked. We picked 1, 3, and 7. Okay? So let's do a little math. Let's see, 2 times 1 is 2 plus 6. That's going to give us 8. And then we have 2 times 3 is 6 plus 6 is 12. And then we have 2 times 7 is 14. Plus 6 is, there you go. And now we have 3 ordered pairs that we can graph. Okay? Any questions? All right, let's do a few more. What are we up to? Number 3? Number 3. Here's number 3. Y equals 3x plus 2. Okay? And so we're going to have a number for x and a numbers for y. And here we go. We're going to pick the number 2. Let's pick an output number of 17 and an input number of 9. That's 17, by the way. Inputs are 2, output 17, input of 9. Okay. So let's do some math here, guys. Let's see, it's going to be 3 times something plus 2. 3 times something plus 2, but we want it to equal 17. 3 times something plus 2. Okay? All right. So let's work this out. We'll put a 2 here, And let's see what that gives us. Three times 2 is 6, and then plus 2. What does that give us? It gives us 8. Clean this up a little. Okay. So for the next one, 3 times something plus 2, we want it to equal 17. 3 times 5? Let's see if it works. What's 3 times 5? And if I add 2, does that make it 17? So 5 it is. That was good. So we figured out that this has to be 5 to get that output. And here we want 9. So we want 3 times 9, that's what, 27? And then we add 2. So what's our output going to be? 29. Thank you. Okay. Let's try a few more. Okay, I think we're going to start to have a few negatives in here. So this is number 4. Let's do this one. Y equals 5 times x, take away 13. Let's try that one. Okay. So we'll put x numbers there, y numbers here. So let's see, we're going to have input of 2, output of 12, input of 8. So let's work this out. So this is our function. This is our rule. 5 times something, take away 13. 5 times something, take away 13, but we want it to equal 12. Okay? 5 times something, take away 13 again. Okay? Let's see. So the first one is going to be 5 times 2. Let's see. Let's work it out. 5 times 2 is 10. And then you take away 13. 10 take away 13. Negative 3. Okay? 10, you remove 13, it's a negative. Okay? So 5 times something, and then you take away 13 from that, equals 12. So think about it. If you remove 13 from what number will give you an answer of 12? Something take away 13 equals 12. What's that something? What number minus 13 will give you 12? Yeah, Francis. 25. 25, right? 25 take away 13. Would that give us 12? So what does this number here have to be? 5 times 5 is 25, take away 13. So this has to be 5. Okay, here it's going to be 5 times 8. What's that going to be? 5 times 8 is 40. Take away 13. Yep, 37. Okay. Yeah. Oh. Yeah. 40 take away 13, yeah. Sorry about that. Okay, there we go. Okay. So for the next one, we're going to have a few more negatives. Y equals -2 times x plus 7. Okay, let's try that. So we got x and y. So let's see, we want to, let's do 2, 4, and 6. Okay, you guys ready? So what's our rule? -2 times something plus 7. And we have inputs of 2, 4, and 6. So we got to be extra careful because we got negatives here, right? So this is going to be -2 times 2, -4 plus 7. -2 times 4, -8 plus 7. -2 times 6, -12 plus 7. Okay. So let's see. -4 plus 7. Yeah. +3. -8 plus 7. -1. The bigger number is negative, so you go with a negative sign. Same thing here. You're going to subtract, but keep the sign of the negative. That would be -5. Okay? Okay. The next one is not meant to be confusing, but because it's the first time we're going to see it, it's going to seem a little confusing. What if I have a function, a rule for number 6 like this? Y equals, let's say, just 3. Y equals 3, that's it. But we still have x and y, right? It's in 2 variables that we want our answer. Okay? So let's say I have this. I have 0. I have 3. I have 17. And for the last one, I want an output of 3. Well, that looks different. What's the rule say? What does y equal? Y equals 3 each and every time, right? So here, y is 3. Here, y is 3. Here, y is 3. And here, of course, y is 3. Okay? So let's see. So when x is 0, what does y have to be? It has to be 3. It's telling you it's 3 in that case. When x is 3, what's y going to be? Well, what's it saying? It's equally 3. When x is 17, what does y have to be? 3. Look, guys, it's always saying y is 3. No matter what number you have for x, y is always 3. So if y is 3, right? What number can I put here? 25 would work. Anything else? 10 would work. 15 would work. 6 would work. It could be a negative number. It could be a positive number. It could be a fraction. It could be a decimal. It could be pi. Any number you want would work. So any number for x would still give you an answer of 3. So any number goes in here, but the answer is always 3 when you have an equation like this. If I would have had y equals negative 3, then every answer for the output would have been negative 3. Okay? Any questions on that? All right, this will be the last one. Number 7. You guys ready? Here we go. Let's do y equals 1/2 times x plus 3. Okay, you ready? Let's do this last one. We got x and we got y. Let's see, we'll do 0, 2, 4, 6, and for the last one, we'll get an output of 9. Okay, so this time we got a fraction to work with, 1/2. So let's see what the rule is. The rule is 1/2 times whatever x is plus 3. But in the last one, we want it to equal 9. So in the last one, it has to equal 9. So let's see what we get. 0 here, 2 here, 4, 6, and we'll figure out what has to go there. Okay? 0 times anything is what? 0. So 0 times 1/2 is 0, right? So really we have 0 plus 3. So how much is that? 3. So the answer here is 3. Now, we want 1/2 times 2. What's half of 2? 1. So half of 2 would be 1, and then you add 3, you get 1 plus 3. That must be 4. Let's see if you can do it too. What's half of 4? 2. And then you add the 3. What does our answer have to be? 5. Okay, I'll let you figure out the next one. You want half of 6 and then add 3. You should also be noticing a pattern there. What are we going to get? What number should go here? 6. You want half of 6, that's 3, plus the 3 here, that's going to be 6. So half of what number when you add 3 to it gives you 9? Well, you can just follow the pattern. We have 7, 8, 9, which would come from 8, 10. What's the next even number after 10? 12. Let's try it out. What's half of 12? 6. What's 6 plus 3? 9. There you go. It has to be 12. Okay. All right. So today's assignment is going to be a couple of IXLs where you're going to be working with these function tables.